This will be a short video on how to start this lab, so if you are not in class, you can follow this video to get started on this lab. So here's the front page. It's identify, predict, and balance types of reactions. That's what we're going to work on. You should also have your yellow sheet and green sheet handy as you do this, and possibly your periodic table. So to start with, before you get to actually do the lab or the reactions, before you get to run them in lab, you're going to have to write out the reactions on paper. So normally you get the reactions on paper, this time you don't. Just checking my pen, it's working, there we go. So in this first reaction you're going to mix sodium chloride with silver nitrate. So you have to take these, they're both ionic, so there's no prefixes, so you know they're ionic, you got to write out their formulas. And when you see the word "and," that means it's going to be a plus. So sodium chloride, I'll actually quick do this one here. Sodium, chlorine. If you check your yellow sheet, they actually have a +1 and a -1 charge, so that is balanced. Silver is Ag. Nitrate, notice it's 8, so it's NO3, not just N. This is a +1, -1 charge as well. So that is going to be the first two compounds. So what you're going to do on the next page, if you flip to, I think this is page 2, it says write a balanced reaction. So we did Na, sodium chloride, plus silver nitrate. And now you're going to have to predict the products of this reaction. To predict the products, though, it's best if you first figure out what type of reaction it is. So it looks like here, this is definitely a compound. This is also a compound. So I've got two compounds. So if I check my green sheet, looks like that matches most closely to the double replacement reaction. We've got two compounds. It's definitely not a combustion. We don't have CH, we don't have O2. Decomp only has one reactant. Synthesis is two elements. Single replacement is a compound plus an element. So double replacement fits that the best. I've got two compounds. That looks like a double replacement to me. So we've got double replacement. So we know that much. Now we have to go back to our green sheet, go over to your double replacement reactions, and figure out what type of double replacement reaction we're working with. So I'll quick write this out so that we can just keep it here. So we've got acid base, acid carbonate, acid salt, base salt, salt salt. So we check, does this start with an H? No. Does it end in an OH? No. It doesn't have a .H2O, so this is just a salt. This one, same thing. It doesn't meet any of our specific criteria, so we're just going to default and say it is a salt. So that is double replacement number 5. So we've got DR number 5. Okay, now we go back, and it says that it's going to make a new salt and a new salt, which isn't the most helpful. But for the most part, if you look at the pattern here, you can look at the examples given, and you'll notice that the potassium and the silver switch spots. So you just take the first elements, so the potassium ends up being with chlorine. So you can see the potassium is now with chlorine, the silver is now with nitrate. So let's apply that same pattern to this. Let's switch the Ag and the NaCl. So the Ag is going to be with Cl. And we got to recheck our charges. In this case, they still fit. They still match. Then the Na is going to be with the NO3. We check +1, -1. It's all good. So this is what I want you to do for the first one. You don't have to draw all the arrows or all this extra stuff, but you need to have this reaction written out. Now number 2, calcium metal with distilled water. So we're going to write out calcium metal, just calcium, it's calcium by itself. Now you should double check, is calcium one of the elements on your yellow sheet that is listed as a diatomic? Do you need to put a 2 there? So double check that. And if you check that, you'll find out that it is not on that list, so calcium is fine being by itself. No 2 is needed. Then water is just H2O. So that's the first half. Now we got to come up with the type of reaction. So let's look. Calcium is an element, water is a compound, so that looks like a single replacement to me. It matches the generic formula of a single replacement. So we write SR, then we go back. Now I check my single replacement reactions. Let's get rid of all that. Calcium is not a halogen. It is not fluorine, chlorine, bromine, or iodine. It is not in group 17. Not in group 17. It's a metal, so that gives me 3 options. Now, is it a metal with an acid, salt, or water? In this case, it's definitely water. We've got a metal plus water. So it is SR number 3. Now let's go back to that sheet. It tells me that metal plus water gives me a metal hydroxide plus hydrogen. Hydrogen by itself is diatomic, so that's why it has a 2 there. If you check your yellow sheet, hydrogen is on that list of diatomic atoms. So I know that one of my products will be hydrogen. That one's easy. Now I've got to figure out what the metal hydroxide is. So let's go back here. Let's write down the gimme here. That's the easy part. Hydrogen, H2. Now a metal hydroxide. In this case, my metal is calcium. And hydroxide is OH. And I have to check the charges on these. Calcium has a +2 charge. Hydroxide has a -1 charge. So I need 2 of these. There we go. So that is the main thing I want you to have done for the lab. The next step that we'll eventually do is we'll check to make sure that everything's balanced. So if we check to make sure it's balanced, I'll change this to HOH. So now that every... okay, sorry, the printer interrupted me. So the next thing, now that every formula is written down correctly, I've got all my formulas balanced. They look good. Now I go back and add the coefficients that go in front of the compound. So if I look over here, I've got 2 hydroxides. I only got 1 here, so I'm going to double this. That gives me 2 hydrogens. Looking at this one up here, 2 times 1. I've got 2. So this 2 is all I have to do to balance this reaction. So let's look at the next one. Number 3 is acetic acid. Now, this one you're looking at, you might be like, how the heck do I figure out the formula of acetic acid? That's nothing like we've learned how to name or write formulas of. And the trick here is that on your yellow sheet, on the bottom of one of the sides is an acid, or a list of acids, and it gives you all the formulas and the names. So you look there, in acetic acid, the formula of acetic acid, there's my reaction, or my place to write it, HC2H3O2. You'll find that listed there. And then, to save time from jumping all the way back, it says sodium bicarbonate. Sodium is Na, or it says sodium hydrogen carbonate, and if you check your yellow sheet, the polyatomics, hydrogen carbonate is HCO3. HCO3 has a -1 charge, this has a +1 charge, so it's balanced. This acid is on your yellow sheet. It is already balanced for you. It's correct, so don't worry about that one. Now to figure out what type it is, we've got a compound and a compound. Doesn't look like combustion, doesn't look like single, none of those. It's definitely double replacement. And so now I want you to go to the double replacement section. We've got the double replacement reaction section. And you'll notice that we've got 5 options here. If we check, acetic acid is an acid. So it's definitely going to be one of these 3. It was called acetic acid. It starts with H. So we know it's not any of these 2. So what is the acid with? Is it with a base? Is it with a carbonate? Or is it with a salt? Now it's definitely not a base because it does not end in OH. And technically, in a lot of other scenarios, we would actually call sodium hydrogen carbonate a salt. But in this case, we're going to be a little bit more specific and say it's a carbonate because acids react a little bit different with carbonates specifically. So we're going to be a little bit more specific on this and call this a DR number 2. And this is important that you make sure you remember that carbonates, we call them a carbonate when they're with an acid, but we just call them a salt if they're with anything else, because they behave a little different with an acid. Now our products, this is where the green sheet is really useful. The products are a salt plus water plus carbon dioxide. Well, water and carbon dioxide are H2O and CO2. So let's go in here and get the easy ones out of the way. On a test, the green sheet would give you 2 out of the 3 answers. Now we just got to figure out what goes here. And it says it's a salt. So let's take a look at our example. In this case, our salt is a metal plus the anion there. So the metal comes from the carbonate, and the anion comes from the acid. So let's apply that to our example here. The metal comes from the carbonate, and then the anion comes from the acid. So we take the first half of the carbonate, the second half of the acid, and we go Na, and then C2H3O2. And if you check your charges, this has a +1, this has a -1 charge, so that one is all set up. So there you go. That's the first 3 completely done. Your job is going to be to go through, I'll even give you this one, it's going to be aluminum plus copper 2 chloride. So CuCl2, because the copper is a +2, chlorine has a -1. So you'll have to figure out what type that is. Obviously write it where it needs to be written. What type of reaction, and then tell me what comes out on this side. Hydrochloric acid, that's an acid, it's HCl. It's added to sodium phosphate, NaPO4. Sodium's a +1, phosphate's a -3, so you need 3 Na. So it's HCl plus Na3PO4. Magnesium metal, that's Mg. It is not diatomic, is with hydrochloric acid. There you go. So I will let you balance these formulas, and that one, and then tell me what the products are. And then let's see here, you got 8, 9, and 10, so go through. You got sodium hydroxide, reacts with aluminum nitrate. Sodium hydroxide reacts with copper 2 sulfate. Sulfuric acid, that's on your yellow sheet, reacts with barium nitrate. So it's a lot of work. You got to write these down, but you have to have the reactions balanced and fully predicted and written out, all 10 of them, before you start the lab on Monday. Or I guess if you're watching this in the future, who knows what day of the week it'll be. But I always make sure every year that I have students write out the reactions before they get to start the lab, actually doing the lab.